Okay, students, sorry for the delay. Actually, now I hope you can see the window all. Now, students, can you see my screen? Right? Students, can you see my screen? Right? Okay. Good evening, all. Welcome back to Civil Engineering eTab channel. Follow us in YouTube link in the link provided below. And these are the Facebook link, and this is the Twitter link and Instagram link. I hope you are enjoying the sessions, and please like, share, and subscribe our channel. So now we are going to start with a topic called index properties of the soil. Now I am going to start with index properties of the index properties of. When we discussed about index properties of soil, the first thing what I want to tell you is why you want to learn about index properties. Index properties are useful for classification and identification of the soil. Index properties are useful for what? It is useful for classification and identification of the soil. Index properties are useful for classification as well as identification of the. If you are students, if you have any doubts, you can please comment. It is useful for classification and identification of the soil. Am I clear, students? Now see, students, when I am telling about it is useful for classification and identification of the soil, actually I will be telling in soil classification topic, students. We have one is fine grained soil, one is fine grained, and another one is coarse grained. Now you can ask me, how do you classify fine grained and coarse grained? It is purely based on the size of the soil particle. Based on the size of the soil particles, they are classified into fine grained as well as coarse grained particles. Am I clear, student? Now coming to this, it gives index properties, it gives rough estimation of engineering properties. It gives rough estimation of the engineering properties. Now you can ask me, now you'll ask me, what are index properties and what are engineering properties? Now you can ask. Engineering properties are nothing but, I can tell you, engineering properties are nothing but shear strength, compressibility, permeability. Shear strength means the strength of the soil. And remember, students, whenever you are designing foundation, you should remember that foundation in the point of civil engineering, in the point of geotechnical, the foundation should not fail in shear. If it is in case of RCC, it should not fail in shear. In case of geotech, it should not settle. So to say, regarding the settlement, you should require some properties of engineering, that are shear strength, permeability, and compressibility. Permeability means if you have a tank and you have a valve, if you open the valve, water will flow. If you close the valve, water will not flow. So the water flowing capacity in soil is called permeability. Compressibility means in voids, you have two things. One is air and water. If you remove air, it is called compaction, and if you remove water, it is called consolidation. If you are removing both air and water, then it is called compressibility. So here what I want to tell you, students, is these are separate chapters, so don't worry about this. Index properties are nothing but consistency limits, relative density, sedimentation, and see, student, coming to fine grain, what are the things which are useful, or means for classification of fine grain? You are discussing about classification if you are discussing about the classification of fine grain, what are the things you are discussing in classification of fine grain are, or by on what basis you are classifying is, one is consistency limits. Consistency limits will be discussing in detail, and consistency limits are also called as Atterberg limits. I'll be telling that in a separate topic. One is consistency limits and other one is consistency limits, and other one we have is, what is the other one we have? Can anyone tell me, students, in the comment section? No. Okay. One is consistency limits and other one is sedimentation analysis. One is consistency limits and the other one is sedimentation analysis. Remember, students, these are the two things which are very important for classification of coarse grain. So you have to know about consistency limits and or Atterberg limits. And now, similarly for coarse grain, what are useful for coarse grain if they ask you? One is sieve analysis. One is sieve analysis. And other one is relative density. Relative. Now we'll start with relative density, students. We'll start with the explaining. So students, in classification of coarse grain, what are the things you are studying is sieve analysis and relative density. In classification of fine grain, you are studying about consistency limits and sedimentation analysis. Am I clear, students? Now coming to the relative density. What do you mean by relative density? You can ask me. What do you mean by relative density? Remember, students, relative density is also known as density index. Relative density is also known as density, and that is the reason most of you students, actually if you see the formula of density, relative density, it will be shown as ID. Now I am writing the direct formula here, Emax minus E by Emax minus E minimum. If it is percentage, you have to multiply with 100. So this is the formula for relative density. Very important formula in all the state level exams as well as competitive exams of civil engineering. Now you'll ask me, see students, relative density is useful for classification of coarse grained soils, which I told you. It is useful for classification of coarse grained soils. Now, as I told you, it is useful for classification of coarse grain. There is another advantage I will be telling you. Okay, it is useful for classification of. Now you'll ask me, what is Emax? Now see students, Emax is known as maximum void ratio. Now you'll ask me, students, when do you say that void ratio is maximum? Maximum void ratio I am telling. When do you say that void ratio is maximum? It is maximum void ratio, and if the void ratio is maximum, that state is called loosest state. So if anyone asks you what is Emax, you can write it as void ratio in loosest state or maximum void ratio. That you have to remember, students. Why? Because in loosest state, voids will be more, hence it will be maximum. Whereas E minimum is known as minimum void ratio. E minimum is known as minimum void ratio. And here E minimum is known as what, students? This is the void ratio. One will be the void ratio minimum. See students, void ratio tells about the voids. So when you say the void ratio is minimum, then it says that it is densest state. So here students, what is Emax is maximum void ratio in loosest state. E minimum is void ratio in densest, sorry, the max is loosest state, minimum is densest state, which I have told you. Now you will ask me, what is the void ratio E called? E is known as void ratio in natural state. Void ratio in natural. Now see students, in the previous up to 2010 or like that, they used to ask what is void ratio, relative density. But now what they are asking is based on relative density. Actually, based on relative density, Am I clear, students? Based on the relative density, we are going to classify. Based on the relative density, we are going to classify whether the soil is very loose like that. So based on this percentage, what is ID, students? ID is nothing but density index. So when density index is 0 to 15 percentile, the condition of the state is very loose. Remember, students, when density index is 0 to 15, the soil condition is very loose. So based on the density index, you are going to tell the condition, or I should say more imprecise, the state of the soil. That would make more sense. What is the state of the soil based on ID? If it is 0 to 15 percentile, it is very loose. If it is 15 to 35 percentile, it is loose. And if density index is between 35 to 65 percentile, it is dense. Dense in the sense you have to sell it is low dense. Okay, if it is 65 to 85 percentile, you have to remember all these values, students. If it is, there is no other way, because if you don't remember, they can ask you what is the state of the soil. They can give you Emax, E and everything. After finding out, if you don't know these options, in the options it will be very loose, dense like that, low dense, dense. And remember, students, if it is more than 85 percentile, then it is called what state? Highly dense state. So here you are not only classifying whether it is not only useful for classification of coarse grain, it is also useful in the classification of state of the soil, whether it is wet. Now you will ask me, sir, why it is not useful for fine grain, why it is useful for coarse grain? Remember, students, the simple formula, if you see Emax and E, all these things, here in relative density we are taking the consideration of the size of the voids also, because based on the size of the void, actually void ratio will not talk about size of void. That is another important thing which we want to tell you. Now why it is useful in the, because after finding lot of practical observations, they have come up with one factor. It is a kind of factor. If I tell you relative density, based on this factor, they are telling that it is helpful for derivation of coarse grain. Am I clear, students? Now you can ask me, please, this is Civil Engineering ETAP channel. Please like, share and subscribe our channel, students. Next we have is, next thing what I want to tell you here is sieve analysis. Are you following, students? Please respond if you have any doubts. Okay. Next one is sieve analysis. I see, students, how the sieve analysis is carried out is very important, students. Now sieve analysis, usually if you see the sieve sizes, suppose if I take a sieve sizes, it will be 4.75, 2.36, it will be 4.75 mm, 2.36 like that, 1.18 like that, it will be so on, 70 up to 2 micron it might be there. Now see, students, you have to remember this table which I am telling. Now see, students, if I tell you sieve size, it is 4.75 mm, 2.36 mm, 1.18 mm. Why I'm talking about 2 micron means I will tell you in soil classification. Okay, next 0.425 mm like that, or otherwise I have one thing else. 1 second. So on up to, because we need not to write all, so on up to, if I tell you 2 micron. Now see, student, this is sieve size. What is this column? This column denotes about the sieve. Now you, how the sieve analysis is carried out means, it is kept on a vibration machine and it will be subjected to vibration and all those things. That procedure you might be aware. After sieve size, you have to calculate weight retained. Weight retained on 4.75 mm, you have to take it as W1, W2, W3, so on up to Wn. Next you have to consider percentage weight retained. Next you have to consider percentage weight retained. When I tell you about percentage weight retained, it is what is the total. If I consider, assume that total weight of the soil before performing the sieve analysis, total weight of the soil, you assume it as W. So what will be the percentage weight retained? It will be W by capital W into 100. Or you assume how to find out X1. Similarly, it will be W2 by W into 100. This you assume as X2. What X1, X2 I am assuming. Now you can ask me what the next step is. Cumulative weight retained. Cumulative means you might have studied in your plus 2. Cumulative means adding all those things. Suppose up to xn. Suppose I am telling you up to xn. It will be what will be the cumulative x1. Here it will be x1 plus x2. So on, if I tell you up to here, it will be x1 plus x2, so on xn. Now see students, this is called cumulative weight retained. This is called what, students? This is cumulative weight. Now what I want to tell you is percentage finer. If I want to tell you about percentage finer, this is called very important, student. Percentage of soil passing or percentage finer is same. Now it will be 100 minus retained minus 100. Because why I have taken 100? Because it is plus. It is a percentage. So 100 minus x1 plus x2. So percentage finer or also is called as percentage passing. Percentage finer is also known as percentage passing. Here it is 100 minus x1, so on up to xn. I hope you are clear in this topic. So what do you mean by sieve analysis, students? If you take different types of sieves, first on each type of sieve, how much weight is retained, you have to know through the experiment. After finding the weights, then you have to follow this table, that is percentage weight retained. After this is how you find out the percentage. Then you will find out cumulative weight retained. After finding out the cumulative weight retained, you have to find out the percentage finer. Am I clear, students? This is what you have done in sieve analysis. Next one, what I want to tell you is, these students, both here sieve analysis as well as relative density, both are useful for what? Both are useful for what, students? Both soil class. See student, this is very important. Both relative density and sieve analysis are useful for what, student? Both are useful for the classification of coarse grain. And how the coarse grain, how it is done, how the what is relative density and what is those things, I have explained you in the problem, sorry, in the slides. Okay, 1 second, students. Next one, what I want to tell you here is, next thing what I want to tell you is, particle size distribution curve. This is one of the important topic, students. If you can understand this, this will make you more sense. This is called a particle size distribution. Most people will ask you. Now when I draw about particle size, in the particle size distribution curve, a graph is drawn between percentage finer, that is percentage finer is nothing but n, and this is percentage finer, and here it is particle size. A graph is drawn between percentage finer is also known as percentage of passing, which I told you. One is particle size and another one is percentage finer. When I tell you about percentage finer, how this graph you should understand. This is one graph. There is another graph. This is another graph. Do you have another graph is? Now see students, this graph is known as well graded. That graph is known as well, and this graph is known as uniformly graded. I'll tell you, don't worry about what is well graded. Uniformly graded. Uniformly graded. And this is known as poorly graded. Now you'll ask me, what they can ask you, these are questions are well asked in all the competitive exams. Okay students, now see students, when I discussed about poorly graded soil, when I discussed about poorly graded soil, if I tell you about poorly graded soil, what is poorly graded soil is some particle sizes are missing. How I will tell you, poorly graded soils means some particle sizes are missing. Now when I tell you about some particle sizes are missing, here you should be very clear in one thing. See students, when I draw here particle sizes, these particle sizes are not there, which means there is some gap here. Okay, so some particle sizes are missing means it should not, some particle sizes are missing. That is the one you have to be remembering student. And one more thing what I want to tell you students is, here in uniformly graded student, if you observe, it is almost like a straight line. So when I tell you about uniformly graded, in uniformly graded all the particles are of same size. That please remember students, in uniformly graded all the particles are of same size. In the, see students, by looking into the graph, if you draw a straight line, here the particles are all of some particle sizes are missing here. So that is why it is called poorly graded. All the particles are of same size. Now you can ask me another question is, what is well graded? See students, in well graded all the it will be, see, well graded means all the sizes are present, particles of all sizes are present. In well graded, particles of all sizes are present. This is very important student. In poorly graded, some particles are missing. In uniformly graded, all the particles are of same size. In well graded, particles of all sizes are present. So this is another important thing which they can ask you in particle size distribution curve. And one more thing they can ask you, poorly graded soil is also called as gap graded soil. Poorly graded soil is also called as gap graded soil. This is another important thing which I want to tell you. Poorly graded soil is also known as what students? Poorly graded soil is also known as gap graded soil. That is another important thing which I want to tell you. Now, there was a previous question asked, in poorly graded soil means what is the shape of a poorly graded soil? They can ask you. The shape of the curve will be like a hump. If you see here, it is like a hump. Am I correct or wrong? See student. Similarly, they can ask you what is the shape, means what is the curve? It is like a steep curve. It's like a and they can ask you how it is well graded. Well graded is something like S curve. It is something like S curve. So this also they can ask you students. The question they can ask you is, well graded soil, all the particles are of same size. In well graded soils, all the particles are of same size. In poorly graded soils, some particle sizes are missing, and it is also called as gap graded. Am I clear students? So with this, what I want to conclude from particle size distribution curve is, in particle size in the particle size distribution curve, first thing is well graded. All the particles of all sizes are present. Its shape is S. And uniformly graded means all the particles are of same size and it is in steep in size. Another thing what I want to tell you is poorly graded soil. Some particle sizes are missing and it is in a hump shape, and it is also known as gap graded soil. So this is what the brief of particle size distribution curve. Next thing what I want to tell you here is, we have another important thing what I want to tell you here is coefficient of uniformity and coefficient of curvature. When I talk about coefficient of uniformity, now you will ask me, see students, whenever you are studying about coefficient of friction, what does coefficient of friction will tell you? Coefficient of friction will give you idea about how the surface is rough. Similarly, whenever you are studying about coefficient of uniformity, whenever you are studying about the coefficient of uniformity, you will also have an idea. You will also have why you are learning coefficient of an uniformity is it gives you an idea about particle size range. It gives you an idea about particle size range. It gives you idea about the particle size range. Am I clear, students? It gives you idea about the particle size range. So this is what you will be learning in coefficient of uniformity. What is coefficient of uniformity? Coefficient of uniformity gives you idea about the particle size range. Another important thing what I want to tell you is coefficient of uniformity is given by Cu is equal to D60 upon D10. Coefficient of uniformity is given by the formula D60 upon D10. Now you can ask me, what is D60? Why you are learning coefficient of uniformity? Because it gives you idea of particle size range. Now what do you mean by D60? Means it is the size of the sieve, or it is the size. This is very important, student. What is D60 means? It is the size of the sieve where 60% of soil particles are passing. When it is D10, I will tell you, D10 is very important. 60% of soil is passing. So what do you, first of all, whenever anyone asks you what is D something, D means first of all it is size of the sieve where 60% of soil is passing. Now see students, whenever I am talking about effective size, whenever I am talking about effective size. Now what do you mean by effective size? I want to describe you. Remember student, effective size means, this is another important. Now you can ask me, what do you mean by effective size? Remember students, effective size means it is the size of the sieve effective size means it is the size of the sieve, means is the size of the sieve where 10% of soil particles are passing, where only 10% means, see as I told you, so that is the reason effective size, if they tell you effective size, they might not give you the means D10 or D60. If they are telling effective size means it is always D10. It is the size of sieve, only 10% of the soil particles are passing, where only 10% of the soil particles are. So this is what you mean by effective size. Am I clear, students? What do you mean by effective size? It is the size of the sieve where only 10% of the soil particles are passing. And remember, effective size is denoted by D10. Now if they ask you D30, D30 means D6. Now based on Cu, please, this is Civil Engineering ETAB channel. Please like, share and subscribe our channel. Now see students, in coefficient of uniformity, when I talk about coefficient of uniformity, for well graded soil, remember this is very important students, for well graded soil or for well graded sand, I should say, for well graded sand or gravel, sorry, for well graded sand, Cu should be greater than 6. See students, if you don't remember these formulas, while solving the problems, it would be very difficult. So for well graded sand, Cu should be greater than 6, and for well graded gravel, well graded gravel, Cu should be greater than 4, and Cu is all approximately equal to 1 for uniformly graded. For uniformly gap graded condition, I'll be telling you, don't worry. Okay, for now you remember this. Well graded sand means Cu should be greater than 6, and well graded gravel means Cu should be greater than 4, and for uniformly graded soil, Cu is almost approximately equal to 1. So this is what you are about the Cu and regarding the grades of the. Am I clear, students? Next one, what I want to teach you here is coefficient of curvature. The next coefficient we have is the coefficient of curvature. When I talk about coefficient of curvature, do you know when you are discussing about when you are studying about mathematics, you'll have curvature topics, right? What exactly curvature will tell you is curvature will give you an idea about the shape. Coefficient, similarly here coefficient of curvature, it gives you idea about the shape of the curve, or it gives you idea about the why you're learning the coefficient of curvature is it gives you idea about the shape of the gives you idea about shape of curve, that is called coefficient of curvature. Now remember, students, coefficient of curvature is given by the formula Cc is equal to d square 30 upon d60 into d10. Very important formula, students. Whenever you are preparing for state level competitive exams like Orissa or Jammu, anywhere, OPSC, Orissa Public Service Commission, anywhere, if you are Karnataka, these formulas will be very important in the service exam. So here what I want to tell you is for well graded soil, Cc should be between 1 and 3 for well graded soil. For uniformly graded, sorry, here one thing I want to add, students. Here coefficient of uniformity for uniformly graded soils, it will be between 1 to 2. A small correction, students. Here coefficient of curvature will be approximately equal to 1. For this is for uniformly. Now I am clear in. Now you've one more important point I want to tell you, students, here. For well graded soil, if a soil is well graded, whenever you are telling well graded soil, students, this is a very important point I want. Cu, remember, students, Atterberg limits are also called as consistency limits. Remember, students, Atterberg limits are also called as consistency. Now when I tell you about Atterberg limits or consistency limits, you should have an idea about this graph. Remember, students, if you are idea having about the graphs, then it would be very easy. This is called liquid limit, plastic limit. This is shrinkage limit. This is dry volume. The graph is drawn between volume. A graph is drawn between y-axis volume and x-axis water content. The graph is drawn between y-axis is y-axis I have shown with volume V, and x-axis I am showing the thing as water content. Now what are the states I have to tell you here? Here it is, one is liquid state, and another one is, this is plastic state, and this is semi-solid state, this is solid state. Now if you ask me what are Atterberg limits or consistency limits, means what are Atterberg limits or consistency limits, you will ask me. Atterberg limits or consistency limits, these are the water contents. Remember students, these are the water contents. Remember, Atterberg limits or consistency limits are, these are the water contents at which soil passes from one state to the other state. At which soil passes from, what are Atterberg limits or consistency limits, means these are the water content at which soil passes from one state to the, that means, see students, this is very important. You see, they are like boundary limits to pass from one state to the other state. If you cross WS, that is shrinkage limit, it will enter into semi-solid. If you cross plastic, it will enter into plastic. If you cross, so all these are, now first of all, what are these? Liquid limit, plastic limit, all these are water contents at which soil passes from one state to the other state. Now there was a previous gate question asked students. Remember that liquid limit is greater than, plastic limit is greater than shrinkage limit. Remember, liquid limit is greater than, plastic limit is greater than shrinkage limit. What I want to tell you here, what is WL is, why, see students, if you are giving a number system here, you are telling a number system, how do you give numbers 1, 2, 3? So based on the graph, it is evident that liquid limit is greater than, plastic limit is greater than shrinkage limit. So what do you mean by WL is liquid limit? WL is known as liquid limit. Are you following students? Any doubts, you can always feel free to ask me. What do you mean by WP? WP is known as plastic limit. WP is known as plastic limit. And what do you mean by WS? WS is known as shrinkage limit. WS is known as shrinkage limit. So from this was a question asked in SSC JE students. Liquid limit is greater than, plastic limit is greater than WS. So please follow this. Okay, this is also very important, student. Next thing what I want to tell you is, I want to explain you about what exactly do you mean by liquid limit, what exactly do you mean by plastic limit, and what are the tests. What do you mean by liquid limit? If anyone asks you, what do you mean by liquid limit? Can anyone tell me what do you mean by liquid limit? Remember students, liquid limit is the maximum water content at which the soil has small shear resistance. Remember, whenever, why I am telling maximum water content means, see students, when you cross, if you see the diagram, when you cross liquid limit, it is in liquid state. If you cross this liquid limit, it is in liquid state. So here what I want to tell you here is, liquid limit is, it is the maximum water content at which the soil has, sorry, I should write not maximum, I should write minimum, because I'm telling small maximum water content if it is not having shear resistance. So the small correction students, it is the minimum water content, means after that water, if you see students, again I am drawing the graph to avoid the confusion. If you see the graph here, liquid limit, if you cross this, it will be liquid. So what is the minimum water content at which the soil has small shear resistance? At which the soil has small shear resistance. When it is converting into liquid, what will happen? A liquid does not have any shear resistance. That is the reason he is telling it is the minimum water content at which the soil has small shear resistance. That is known as liquid limit. Now you can ask me, liquid limit is determined by what apparatus, they can ask you. Liquid limit is determined by an apparatus known as Casgradus apparatus. Liquid limit is determined by an apparatus known as what, students? Liquid limit is determined by an apparatus known as Casgradus apparatus. This is another important thing which I want to tell you. Liquid limit is determined by an apparatus known as Casgradus, or it is the minimum water content at which the soil has small shear resistance against the flow. Now actually liquid limit has another important definition, students, which I want to tell you now. See students, actually based on the number of blows, students, the liquid limit definition is getting into picture. Now what is that liquid limits? Means I am writing the definition first. It is the minimum water content at which a soil cut by a groove of, at the rate means, for my terms, at which, again you will ask me, sir, why you are writing at the rate? It is the minimum water content at which a soil cut by a groove of standard dimensions, will flow together for a distance of 12 mm under an impact of 25 number of blows. Will flow together for a distance of this is entire practical definition, students. Is flow together under a distance of 12 mm. I'm writing the definition, so I'm writing it very fastly. Will flow together for a distance of 12 mm under an impact of 25 number of blows. This is what I want to tell you. See, this is also a practical definition. If anyone asks you what is the practical definition of liquid limit, is it is the minimum water content at which soil is cut by a groove of standard dimensions will flow together for a distance of 12 mm under an impact of 25 number of blows. Now see students, what I want to tell you is how the experiment is. Suppose if you are basing a rubber, now a soil is cut by a groove and you are applying a number of blows with an hammer, 25 number, you will be adding water, and that at which water it will move for a distance of, at that water content, it for 25 number of blows, and it has to move for a distance of 12 mm. That will be considered as liquid limit. Am I clear, students? If I some question, this was a previous competitive question. If the base is softer than if the base is softer than, here I told you the base is rubber, students. This is very important. What I want to tell you is, if the base is softer than rubber, remember, softer than, if the base is softer than rubber, students, liquid limit increases. That is very important, student. If the base is softer than rubber, liquid limit is increases. This is also very important, student. Why liquid limit increases, students? You have to be very clear. Why? Because if the base is softer than rubber, you will require more number of blows. When more number of blows, then obviously the liquid limit will increase. Am I clear, students? So the practical definition of liquid limit is, it is the minimum water content at which soil cut by a groove of standard dimensions will flow together for a distance of 12 mm under an impact of 25 number of blows is known as what, students? Is known as the liquid limit. So there can be a previous competitive question. If the base is softer than rubber, liquid limit always increases because you require more number of blows. That is the reason you have to be clear in this. Next, now see students, I want to ask you another important point is how the flow. There was a concept, students. Sorry for the inconvenience, students. You are getting some noise and all. Okay. Here what I want to tell you here is, now coming to the flow index. Please like Civil Engineering ETAB channel, share and subscribe. Please like, share and subscribe our channel. Okay, one second, student. Now coming to the next, now we have come up across a concept called flow curve. What is a flow curve means? A graph is drawn between a graph is drawn between a graph is drawn between one second. A graph is drawn between this concept is very important. A graph is drawn between number of blows and water content. Now see students. Actually the graph will be like this students. See students, more water content. This concept is very important students. Some people will understand in some other way. So this I want to tell you more clearly. See students, if the water content is more, definitely the number of blows will be less. If the water content is less, the number of blows will be more. Now students, as far as I observed, how to convert a curve into a graph, most people might not be aware of this concept. To convert a curve into a graph, if we apply a slope, if we apply a if we apply logarithm to the x-axis, okay, or if we apply logarithm to the x-axis, then it will becomes a straight line. This is a very important mathematical concept student. To convert a curve into a straight line, if you apply logarithm, then it will be converting into straight line. Now see students, how it will be converted into a straight line I will be telling. If you draw a graph between logarithm, suppose this is a curve, why it will become a straight line if you convert into a logarithm means, if you consider log 1 value, it is 0 students. If you consider log 100, it will be 1. So for x-axis variation of large x-axis variation, the y-axis variation will be very less, so that even though the lines, even though they are not on the same line, they will be very close, so that we can draw a line. Am I clear students? Now this is another important point I want to tell you now. Slope of flow curve is known as flow index. Most people, based on this curve, if you remember this curve, you can understand the concept student. Remember, slope of flow curve is known as flow index. This is another important point I want to tell you. Now actually if I tell you slope of flow curve is known as flow index students. Now what is flow index? Actually it is represented as IF. Now if you know any straight line equation, what is the straight y is equal to mx plus c, what is the straight line equation students? It is nothing but m is equal to y2 minus y1 by x2 minus x1. Similarly, see students, here it is a decreasing curve. Why it is decreasing curve is more water content, less number of. So you have to write here flow index is equal to, decreasing curve is different. You have to understand that also student. W flow index is given by the formula W1 minus W2 upon log C students. Here it is N2, here it is N1. Why it is written as W1 minus W2? Because it is higher value. That is why it is called decreasing curve. Log N2 minus log N1. If I draw this, what is log A minus B formula? So flow index is given by the formula W1 minus W2 upon log N2 by N1. Am I clear students? So if you can understand this concept easily, what is flow curve? Flow curve gives you idea about the shear strength of the soil. Sorry, slope of flow curve means W1 minus W2 divided by log N2 minus N1. Now if you ask me, why do you want to learn about flow curve? If anyone asks you why you are learning about flow curve means, it gives you idea about the shear strength of the soil. It gives you idea about shear strength of the, what is flow curve students? Flow curve gives you idea about shear strength of soil. The slope of flow curve is known as what students? Slope of flow curve is nothing but the flow index. Now When you are performing the test, soil passing through which micron is used? This is another important question they can ask you, student. Soil passing through 424 micron is used in this test. Means whatever the soil which you are using for this test, that soil should passes through 424 micron sieve. This can be a question asked in previous. Soil passing through 424 micron is used in the test. Am I clear, students? And this is a standard bit you have to remember, students. The derivation is a different part. Shear strength at liquid limit. If anyone asks you, the shear strength at liquid limit is this, you please remember as a note. Shear strength at liquid limit is given as 2.7 kilonewton per meter. Remember, students, the shear strength at liquid limit is taken as 2.7. Now see, students, flow curve gives you about the idea about the shear strength of the soil. What is a flow curve means? It is a graph drawn between water content and the number of blows. It is a graph drawn between water content and the number of blows. Am I clear, students? And when you draw the graph, it is in which shape, students? It is in which shape, student? It is in a curved shape. To make it a straight line, you are applying a logarithm for to apply. Okay. Now slope of flow curve is equal to flow index. Flow index is given by the formula IF is equal to W1 minus W2 upon log N2 minus log N1. And here the slope of flow index is given by the formula IF is equal to W1 minus W2 divided by log N2 by N1. So this is the formula for slope of flow index. Now remember, students, it gives you idea about the shear strength of the soil, and soil passing through 424 micron is used in this test, and the shear strength of the soil at liquid limit is 2.7 kilonewton per meter square. I hope you have enjoyed the today's session. Please like, share and subscribe Civil Engineering ETAB channel. Thank you all.